So we're talking about collecting information for surveys and experiments. And more specifically, we're going to talk about how to collect it in a way that makes the information valid and accurate. So we have two sources of information, primary and secondary. Primary sources of information are when you go out and do the survey and you collect the data yourself from scratch. Secondary sources of information are sources such as Stats Canada. So if you go to Stats Canada, you could find information about physical activity for children between the age of 12 and 17. And you can download this information that's already been collected. So that's secondary information. That's a secondary source. So suppose we have plans to put more bike lanes in Mississauga. We want to ask the residents of Mississauga, do you want more bike lanes? So we could send them a survey and we could say yes, no, or unsure on the survey. Now, who we choose to ask, that would be how we sample the population, which we talked about previously. But now we're just talking about the survey itself. So you might put a question on the survey that says, do you support adding more environmentally friendly bike lanes in Mississauga? In this case, we would not get valid data from our survey because we've made the question to be biased towards adding more bike lanes because we use the term environmentally friendly. There are a lot of factors that go into choosing whether to use bike lanes or not. The environment is one of them, but it probably should not be part of the survey. So this is what's called response bias. Okay? Surveys are affected by response bias when people react to how the survey is given. What if the survey was administered by somebody who has a bad demeanor? What if he yelled at you and he said, hey, do you want bike lanes? You might be inclined to say no. And this also is a form of response bias. So how you ask the question is very important to the data that you collect. What if you were measuring the height of all the residents in a small town? You wanted to know their average height, for example. And you measured all of their heights, but you didn't tell them to take their shoes off. If you didn't tell them to take their shoes off, then all the measurements would be inflated. They'd all be about a centimeter more than what they should be. This is called measurement bias because all of the information, in this case the heights, are going to be shifted in one direction, namely they're going to be increased. Here's a survey that asks people to give their personal favorite color, and it only gives them 4 choices, and all the choices are variations of pink. This also, it's a little bit silly, but this also is measurement bias because all the answers are going to be some kind of pink color. You may have seen one of these before in a public bathroom. It's a little electronic device where you press one of the buttons and you can tell the hotel or the mall or whoever and give them some feedback about how clean their washroom is. And you have 4 choices to pick. You might wonder if this is a good way to ask customers this question. I would argue that if you like bathrooms to be very clean, you probably don't want to touch anything that's in a bathroom, and you're probably not going to rate the bathroom using this device. So I would say that that would skew the results and make it seem like the bathroom is cleaner than it really is. This we call a non-response bias. It's called a non-response bias because, well, some people participate in surveys and others do not, right? We have to take a sample of our population. If the people who don't respond would have answered differently than the people that did respond, then there's bias because we need to have an accurate sample of the population. So this is called non-response bias.